All right, so the first topic that he will go through with you, and he normally does, is the topic on number systems. Yeah, so hopefully you all know binary. Computers use binary, but they actually, and you should know what decimal is, and that's like normal counting. And the other two that you may or may not have come across before is the octal and the hexadecimal. Yeah, so anytime you hear octal, octal is 8. Hexadecimal is 16, binary is 2, and decimal is like 10. Yeah, so keep that in the back of your mind. That one thing I have to remember. Okay, I use that all the time, like majority of the time. Decimal, the number for 10, binary is 2, octal is 8, hexadecimal is 16. So if I zoom in on the top here now, we know binary is zeros and ones. Yeah, decimal is normally go from 0 to 9, which makes sense. Okay, you could form any number that you want using the numbers 0 to 9. Octal is 8 numbers including 0, so therefore you'll stop at 7. It doesn't really go up to 8, so be careful, right? It starts at 0 and it's 8 numbers, so it's not going to end at 8. So it'll be 0, 1, 2, 3, 4, 5, 6, 7. Yeah, because it doesn't start from 1. Start from 0, right? Hexadecimal, it starts from 0, so it'll be 0, 1, 2, 3, 4, 5, 7, 8, 9. And it continues, but they do write 10, 11, 12, 13, 14, 15. When you reach 9 of them, just start with the alphabet. They'll go A, B, C, D, E, F. So it's like a count to the 15, but from 10, you started to count to the ABC. It kind of cool and way at the same time. So you're going to start from 0. If your count is actually 16 numbers, so 0 up to F is 16. You can count it while I'm doing through. But you start from 0 up to 9, and from 9 to go 10, 11, 12, 24, 15, you just replacing those with A, B, C, D, E, F. Yeah, that is all hexadecimal. You are counting to 15, like F is 15, but you're not gonna write 15. Yeah, that is how weird it is, but that really all it is. So if somebody say B has a value, and B is 11 in hexadecimal, but you're not gonna write 11. You just write it as B. Yeah, it's just the way how they write the notation. You just have to know it goes from 0 to F. After 9, it gonna go A, B, C, D, E, F. Yeah, and that really all it is. Just for you to remember it and become accustomed to the notation. And after that, it's very simple. All right, have a table here. I'll send you all the notes. I'll go through this so you'll know and you'll be able to with it. All right, I record and so you can look through the recording. And when I post up on the YouTube channel, it'll be private. So I'll kind of like separate the video so it will be like just one long video that I had to watch. So I'll name it separately so you know, right, this talking about this. So it won't be too long and dreary. Anyway, so I look to continue. Right, first thing on the list, the question that I may ask is like calculating the amount of numbers or items a number may represent, right? So remember you have 4 systems. All right, you can think of it as the weight of it. So say you have a 10-pound a bag of marbles, and you might want to know, well, how much marbles actually make up the 10 pounds. So you had to actually have to calculate how much marbles in the bag. So think of it as if you have like 15 in hexadecimal. So if you want to write it, you just write 15. And the subscript here is whatever base the 15 in. So if you say 15 in hexadecimal, you just write a little 16 on it here. If you want to write 15 in octal, you write a 8. If you want to write 15 in decimal, which not true, you can't do that. So if you want to write 15 in decimal, you could write 15 to the power to subscript at 10, but you really write it 10, you just write 15 because we know 15 is just 15. Yeah? So wherever this is here is wherever base it in. And you have to keep that in the back of your mind. So if you see 129 and an 8 at the bottom, you know you're in the octal system. Yeah? So be careful. If you just see 129 alone in the decimal system, the 10 is understood. Yeah, and obviously if you see 16 as hexadecimal. Binary, you will see 2, but we know binary is ones and zeros, so it might look like 0, 1, 0, 2. Yeah, so you'll never see 1, 5, 6, 2. That doesn't make any sense because 5 and 6 doesn't exist in the binary system of numbers. Yeah, so the formula trick. Yeah, binary is zeros and ones. You can have a million and one zeros and ones. Once it's zeros and one is binary. Once you add a two, three, whatever it is, you're no longer in a binary system. All right, so let's get into this quickly. Shouldn't take long. Yeah, that's way to remember these steps and just practice a little bit, right? So let's try some examples. So if I have these steps here, so what I had to do, and let's do it. I'll use an example. Let's say we had 23 to base 10. So, right, very simple, right? So the first thing you do, just count the number of digits and then subtract one, right? So you have two digits here. Yeah? So you just subtract one. So two subtract one is two, right? So sorry, two was one. Okay. Anyway, so once you do that, you start with the digits. So all you're gonna do, let's look through it here. That already stops for now. So two and three, you subtract one from two, you get one. So you're gonna start with one on top here, so it'll be one, and this will be zero. Yeah, that's how it does go. So after this now, you kind of like doing it like I used to do in primary school. So it'll be 2 by 10 to the power 1 plus 3 by 10 to the power 0. And you just add it up together. So this would be like what, 20, and this would be like 3. And you get 23, which makes sense because I need some decimal system. But let me say I was 23 to like 8. Yeah, it'd be same steps. So two digits here, subtract one, you get one and zero, which makes sense. After all, you get accustomed to it. So like if you see four digits, you'll like start with three. So I just break down these steps real to the bone. So if it seem like plenty, somebody stop understand, right? So in this case here, it will just be 2 by 8 to the power of 1 plus 3 by 8 to the power of 0. So there's like what, 16 plus 3, and that is like 19. Yeah, so let's have 19. Yeah, so anytime you convert and add the arcs here, how many elements in the system by the steps, and it will always convert to decimal. So the base will always be 10, no matter where you convert it to. Yeah, because the amount of something, it can only represent it as a decimal or in the decimal system. If something had like 23, you can express it in the binary form because binary doesn't have 2 and 3. Yeah, so you always convert to decimal when you're trying to find the amount of something, right? So let's try another one. Prep something in hexadecimal. So 2, 3, 4, let's say 0.5. We get confused with the point, right? So we know this is 2, 3, 4. So this is gonna be 2, 1, 0. Don't get confused with this one. Just gonna continue decreasing. So it'll be -1. If you see a decimal, do not count the part with decimal, right? You stopping at the whole number. So you go 2, 3, 4, and you're stopping right there. Do not count the 5 when you're doing it. Yeah, that is something different. Okay? So this has on this side is 3, so 3 subtract 1 is 2. So it'll go 2, 1, 0, then -1. And yeah, that's continue the number. So now it will be in hexadecimal. Now I want to convert it. So this was already 16 here. So it just be 2 by 16 to the power 2 for the first one, plus 3 by 16 to the power 1, and then plus 4 by 16 to the power 0. And then it'll be plus 5 by 10 to the, sorry, 16 to the power -1. Yeah, and when you add all of that together, you'll actually get the amount of numbers in it. Yeah, and that's literally all it is. It don't matter what it is. But only thing I have to remember is that, well, depending on what number they give you, like if they give you this 2, 2, 5, 6, say they give you some marking like that, you ought to know, all right, this here will be 3, 2, 1, 0, and then this will be -1, -2, -3. And you just go down the road. That is the powers. You just go down. You notice the 16 here. You just put the power underneath whatever number you see. And you just add it up together. That is the steps. It really matter what it is. The steps here, after you get the worksheet, you can reach the steps more in depth, but those are just the general idea that you're doing. It really matter what number. If you're converting something, let me say from binary, and I want to know the amount of elements in this, it's the same idea, right? So this will be 3, 2, 1, 0. I converting using the binary system. So it'll be 3 by 2 to the power 3. And that's plus what, 0 2 to the power 2 plus 1 by 2 to the power 1 plus 0 by 2 to the power 0. Right? That's added up together. Yeah, it really matter which order you're in. Even if it had a decimal point, it'll be the same idea. You'll just go to -1, -2, and so forth and so forth. Yeah, and that is the idea. All these points here basically summarized in that. Yeah, so that is literally it. It really matter what number they give you. All right, so I think I had some examples at the bottom. So, small thing. All right, so that is the substitute box. So just don't forget when you're reading through the stuff, when you get the answer, don't forget to put it to the subscript at 10, right? So whatever number you get, you have to put the little 10 at the bottom. Okay, make it wrong. Yeah, so like this one, if I do it quick, 2 to the power 3 is like 2, 8. 8 by 3 is what, 24. There's 0, there's 2, and there's 1. So 24, 26, 27. So the answer would be just be 27. And you don't forget to put the little 10 at the bottom. Yeah? Once you do all them stuff together, that is it. And that is the answer if they ask you calculate the number of items or elements a number represents. Yeah? So every number in hexadecimal, same thing. You multiply them by 16 to whatever power. If it's an octal, it would be 8 by whatever. If it's in binary, it will be 2 to whatever power it is. And to get the power, same step. We just subtract 1 from the numbers. This kind of redundant. Once you catch the pattern, you don't really have to subtract by 1. I just break it down very plenty for you. And it just go down. Normally, you will realize that the number before the decimal point or the last number, if it doesn't have a decimal point, is always 0. Yeah? It's another way you could do it too. Instead of starting from this side here, you could just start from the end of the number and just increase up. That's another way you could do it too. So like if you have 5, 4, 5, 7, 6, and you wanted to know what the powers would be to find the amount of elements, you could just like start with 0, 1, 2, and 3. You do like that too, you get the same answer. Yeah, you can actually start from the end and then go forward. Yeah, just pick one and know where you do it. It's the same thing for no matter what base you're in. Yeah, and that's all that matters. That's all that matters. All right, so now if you have any questions, you can stop. All right, other than that, I'll just continue. All right, well, I did examples already, so I'll just do this just for understand it. So let me say 123. Let me say it was in the octal system, and let me say 23 was in the hexadecimal system, and let me say this one was in the binary, well, can be binary, so octal. Have any more? Well, let's do 3. So this one, same steps. So this will be 0, 1, 2. So it'll be 1 by 8 because I need octal system to the power 2 plus 2 by 8 to the power 1 plus 3 by 8 to the power 0. Yeah, this will be what, 64 plus, what's that, 32. So 8 by 2 is 16. And there's 1, 6, so it'll be 0. So it'll be 1, 6, 7. I believe that is the answer. Yeah, 6. 8, 81. Yeah. To the power. So yeah, put the 10 at the bottom. If the math's wrong, but what? Very good. So 23 same idea, 0, 1. So it'll be 2 by 16 to the power 1 plus 3 by 16 to the power 0. And this will be what that's 32 plus 3. And that'll be 35 to base 10. This weird looking thing, same idea. Just don't make the mistake with the decimal point, right? So this will be 0 and 1 here. And then this will be -1, -2, and -3. So it will be 1 by 8 to the power 1 plus 2 by 8 to the power 0 plus 6 by 8 to the power -1 plus 2 by 8 to the power -2 plus 5 by 8 to the power -3. All right, and then I'm gonna do that right now. Catch the idea. When you have the polar there, you write the answer, and that's pretty 10 at the bottom. Yeah, and that's it. That's the first part. And the first thing you should you will see in so slides. All right, and very important to know. All right, we probably try that one. Oh, low key. All right, so nice. So again to the fun stuff, right? Conversions. Yeah, so that's really where you're gonna get the most amount of pain from. But once you understand these steps, it very simple. Once you practice a couple of times, the rest of right. So this here, make sure make a mental note of this. Take a picture of it in your brain. Make sure you know the ins and outs of it. Why you need to know what you can and cannot do straight, meaning that you don't have a set of steps to go from one to the next. Think of it as when you're taking a plane, it might have a flight going straight to where you want to go, or you might have to take connected flights. Yeah, so if I need a decimal system, if there's me here, right, and I want to reach binary, I know I could just go from decimal to binary straight, meaning I have steps that I could use to just convert. Even if I was in a binary system, I could have go straight to the decimal system easy. Yeah? But if any binary system, same thing. You have something to go from the binary to the octal, and it could go from the octal to the binary. Yeah? Very simple. Same thing for the binary to hexadecimal. You could go from the binary straight to the hexadecimal, or from the hexadecimal straight to the binary. But you notice it has no link to go from the hexadecimal straight to the octal, or from the octal straight to the hexadecimal. And there's no way to go from hexadecimal straight to the decimal, and there's no way to go from the decimal straight to the hexadecimal. You see, that it have no link. So those two, you have to take a connected flight, and the thing does connect everything together is binary. Yeah. So you have to be careful of that. So if so say in a question convert between a hexadecimal number to a decimal number, you have to know, all right, I have to go to the binary first, and then from the binary, then I could actually go to the decimal. Yeah. So even though you might know these steps as yes, you need to keep this in your mind. So you need to know what you could and can do, and what you need to do before you could do what you need to do. Yeah. So this is very important. Decimal is normally where you start from, because that's like all the numbers. From the decimal, you get binary. Binary separates into the octal and the hexadecimal system. Yeah. So you need to know where you can do. Anyway, yeah. So you need to learn to convert between the bases. Yes. So it's kind of understand because you do not degree. Anyway, so I look to start, right? So at any point in these steps that confuse you, just stop now and I will clarify it, right? All right, so decimal to octal or binary. So you could go from the decimal system straight to the octal or the binary system, yeah, with like minimum steps. All right, let's have a shortcut method, and let's have the method that's wanted to use. All right, but before I want to show you the shortcut method that I just use, and then well, you just keep it in the back of your mind. As I told you before, remember you're just doing a quiz. So it's not like you grading your steps, because this not gonna come on the finals. So once you know to get the answer, nobody cares where you use. All right. So let us go something like this. This is to go from the decimal to the binary. Specifically, only. Yeah, this is only for this. Yeah, do not go using this for hexadecimal and octal. You will get the answer wrong. All right, it's like the shortcut. Yeah. So all you're gonna do, we know how the binary does work. We know binary is 2. Yeah. So keep that in mind. You know decimals is literally like all the numbers that you could know from 0 to 9, right? So how it does work it now? Let's say we had a number, let me say 23. And 23 was in decimal. And you wanted to convert this to binary, right? The shortcut method to do this is you could work the answer in terms of the powers of 2 and then separate it. So watch it. Let's work like this. So let me say we know 2 to the power 0 is 1. So we can write on this side. We know 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. And it could continue on and on and on and on and on, right? That's everybody should know that from now. If you don't know, let's use a calculator. So there's 2 to the power 0, there's 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and the pattern will just keep on continuing over and over and over to infinity and beyond. Right? The idea is, well, after you write this out, you can write this out in a table. Personally, I like to write it out in a straight line calculator, just see the number one time. So all you're gonna do is you're gonna look at these numbers 32, 16, 8, 4, 2, and 1. Just ask yourself, what combination of these numbers I could use to get 23? Yeah, yeah, that's what you're gonna do. Underneath the ones that you could use, you're just gonna write out 1. And after you write out 1, anything else that you don't need, you just put 0. Yeah, and obviously the 32 part, I don't need it. So I could just erase it. Okay, after, kind of like before the numbers, I don't need it. How you just do it, you just normally count up then the powers are 2 up to the max you could get to the number once you don't go over. Yeah, okay, it wouldn't make sense if you go over, but you can't himself use it. Yeah? So right now here, I want to get 23. So using the minimum amount, so 16, I could use 16. If I use 8, I'll end up with 24. So that's past 0 there. I could use 4, yeah, and 2 and 1. Yeah, so 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. Yeah, so 23 in the binary system would just be 1, 0, 1, 1, 1 to base 2. Yeah, that's the idea. But try one more using the same system. Let's erase the pink. Let me say you wanted to write 65. So obviously you notice I need to increase the amount of numbers I have there, right? So we could probably go 2 to the power of 5, that is what, 32. 2 to the power of 6, that should send me over. Check it in my calculator. I remember the bases off the top of my head so easily. So I see what I'll get. 2 to the power 6. 64. Like I'm straight. Nice, 64. Alright, so with these numbers here now, I want to get 65. So obviously you see, and I could just use 164, no 32, no 16, no 8, no 4, no 2, and I could use the 1 to get the 65. Yeah? That's literally the idea. It really matter what number they give you. So like if you start off with the basic ones, like the ones I expect you to know, like 0 to 9, it's the same idea. So if I want to know 1, 1 is just, well, 1. Yeah, so like if I just do it, so I could do that. I'll do it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We could go 10 if I want to. Right, so if I do it now, I'll write in red. 1 in binary, all these here are the decimal numbers except 10, because I just went one extra, right? If I want to write 1 as a binary, 1 is just 1. Yeah? 2 is just 1 here and 0 here. So it's just 10. 3 now is a 1 here and a 1 here. Because I need a 2 and a 1 to get 3. 4 is just, well, 1 here and a 0 and a 0. 5, I need a 1 here, no 2, and a 1. So that'll be 1, 0, 1. 6, I could use a 4 and a 2. So it'll be 1, 1, and a 0. 7, I need a 4, a 2, and a 1. Yeah, 4, 5, 6, 7, yeah. So 1, 1, 1. 8, I need what? So it'll be 1 here and 0, 0, 0 for everything else. 9, what I need a 8 and a 1. So it'll be 1, 0, 0. For the 4, I need 2 and then a 1. 8 plus 1 is 9. So it'll be 1, 0, 0, 1. And 10, same idea. To get 10, I need a 1 for the 8, no 4, and a 2. So it'll be 1, 0, 1, 0. And well, if you want to continue the pattern, the same thing. To get 11, you need the 8, a 2, and a 1. So it'll be 1, 0, 1, 1. And the pattern will just continue. Yeah, that's what I do. You just use any numbers here and pick any combination to get whatever you want. And whatever order you write it in, you just write it out. That's all it is. So it doesn't matter what number they give you. As it once you notice, hey, I need to increase it, just increase it up. And just do your little maths, work it out to what to get it, and you get you. It only have one possible combination that you could use. So you can't really get it wrong. Okay, you can't pick 3/16. Yeah? So obviously you'll notice I had to pick the biggest one first and it just trickle down. Yeah, normally once you pick one, everything else just fall in line. Yeah, okay, that's looking at the numbers. So that's the trick. So go from decimal to binary real quick. Yeah, it really matter what. Like if I had 100 to base 10, 2 to the power 7, like 132, I believe so. Should be. Well, 64 by 2 is like 132. So I will just use 64 for now. Yeah, I can't go over it. So if I wanted to write 100 now, I need the 64 for sure. I need the 64 and 64 plus 32 as well. 96. I need the 32. So I need 4. So I'll be 0 here, a 1 here, a 0, and a 0. So that end up being 1, 1, 0, 0, 1, 0, 0. Yeah, I'll be 100 and binary. We figure you 2 at the end. Yeah, that's all it is. So go from decimal to binary real quick, like real quick. Yeah, that's the method. Find on YouTube. And I always use way quicker, easier. You're not gonna get graded for steps because you just want the final answer. Because it's a quiz, so you don't really have any steps. Once you know how to get the answer, you get the answer. All right. So that is it. That is the shortcut method. Note, I just went from decimal to binary. This doesn't work with octal and hexadecimal and all that other stuff. Yeah, so just keep that in mind. Know when you could use what. Yeah, and that is steps. All right, so just go back to what we were doing and run through this quickly. So let's see. So as I said before, go back to decimal, going from decimal to octal or binary. So I just show you the shortcut to go from decimal to binary. So now we're going to get into the steps. This is the method so we wanted to use, and this should be the method that he will explain to you in class when he goes through the stuff. That's all I know. This man is moving real fast. So he might actually finish this in one class. So yeah, really had to be on top of his stuff. But the thing about this Marcus, so majority of his quiz questions gonna repeat. So you really had to push yourself too much. I mean you could get A plus in this course. You have the resources. So very good. I break everything down into steps. So when you're going through the material again and after I send you could like internalize it a little more, right? So as I said before, thing you have to remember when you're doing this, they have to have a method where they're going from a whole number or a fraction. So you have to remember and you have to keep that in mind. So like if you have 16 to base 10 and you want to convert it to octal, the steps for that different than if you have like 16.5 to base 10 and you want to convert it to octal. The steps with these two are different. Keep that in mind. Yeah, this is a whole number, different steps. This is a fraction, or it has a fraction in it, different steps. So paint any picture in your brain so you could see it, right? So not the same steps. Keep that in mind. Are really important to remember, right? So let's go into it. So the steps here, the table. So let's go through whole number. So let's say we have 16 to the power of 10. Remember, we're going from decimal to whatever, right? So the steps just go like this. Once you remember it, you're not going to forget it. You need to divide the number by the required base you're converting to. Yeah, so if you convert into base 8, you divide them by 8. If you convert into binary, you divide them by 2. If you convert into hexadecimal, which is not really something you just do with this here, you divide by 6. We really use that. It's have an easier way to convert from the decimal to the hexadecimal. So you could go through the binary number to that. Keep that in the back of your mind. Yeah, okay, trick you real easy. You don't have method or easy method to go straight from decimal straight to hexadecimal. You have to go through the binary and then go to hexadecimal. Right? So you divide the number by the required base. So let's say you wanted to convert this here to base 2, which is binary, right? So you know you'll be divided by 2. Yeah, I'll do the question after the rest. All right? But when you're doing that now, you're looking for the quotient. Remember, the quotient is basically how much times whatever went in to whatever it went into. So like if you have 4, I divided by 2, 2 into 4 is 2. So 2 is the quotient. Yeah, so how much times the thing went into it is what you're looking for. Yeah, and that will all the magic going to happen when you're using this step. Yeah, so that is step 1, step 2. You have to record this quotient, because this quotient is basically we're going to be using over and over and repeating the same steps on it. They're really not going to change. Yeah, it's really not going to change. Right? The remainder is the lowest order. So after you get the quotient, the remainder is whatever you get is the lowest order. Meaning the lowest order means that whatever you get, and I will show you all what lowest order means in a bit, so I'm not going to confuse you all with that. But when you write, the numbers are always written from the most significant to the least significant, which is like you write it from the thing that had the most power down to whatever the least power. So when you're writing it in terms of these, when you're actually converting it to something else, when you're writing it out in the answers, the least does go first. So it will kind of be flipped, but you'll see that's not, don't worry about that one, right? So step 4 is going to repeat the same thing as I say over and over, using the quotient. You can't keep on doing that over and over until you can't do it anymore. Basically, when the quotient is 0. It's like if you have 3 and 4, the quotient is 0. You can't do it anymore. Yeah, that's when you know when to stop. Yeah? And step 5, you then write the number. And as I say, from the last remainder up to the first. So remember, what I told you all is the least order digit. So all of them least order. So basically, the last number will be the most leastest, if that makes sense. Yeah, so it'd be least, 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 least. He was the first least, and he was the last. So technically, he will be the most significant. So when you're writing the number, you always write the number from the most significant bit down to the least significant bit. So the number of a number you get, you write in this order. It'll be the opposite for fractions. We realize the steps kind of inverted. Yeah, but the most significant bit is normally the last number that you write when you're doing it like this. Yeah, so let's keep that in the back of your mind. All right, and after you do that, that's really the end of it. See, that's right for the number. It'll be the same thing going over and over and over. All right, so 16, we really write the 16 here. 16 and binaries are set as zeros and stuff. But if you wanted to do it, say you wanted to convert 16 to base 2, you divide it by 2, you get 8, and you divide it by 2 again. But sure, this stops out. So let's see if we can do a question now. Let's see if I have one. So that's a big number. So let's use a smaller number for now. So let's say 16 to 10. That's so you can understand the concept. But when you juggle it with big numbers, so now, right? So we know we convert into binary, right? Binary is 2. So the step cells, so right here, I just use our table. They're easier for me to see, right? So 16, we know we divide them by 2, right? So 16 divided by 2 is 8, right? Yeah, 8. Yeah. So keep that in the back of your mind, right? So now this 8 here is where you're going to use here again. Yeah, so 8 here, bit is 1. Yeah, and then 8 come down here, divide by 2 again, you get 4. And that's going to repeat in the same steps over and over. So remember, if you go back to the steps on top, the remainder is the lowest order. Yeah, so that's keep that in the back of your mind, right? So always go in reverse over and over and over. Yeah, so let's see how we go do that now. So divide this by 2, get 8. Where's the remainder? 0. Bring down each 8 here now, divide by 2 again, you get 4. Where's the remainder? 0. The 4 we're going to use again, divided by 2. Where's the remainder? So this will be 2. Where's the remainder? 0, right? Bring down the 2, divide by 2. Where's the remainder? We get 0 again. We bring down the 1 and divide it by 2. 1 can divide by 2, right? So the quotient is 0 and the remainder will be 1. Yeah, see that? It's the same steps over. So now we know that this here is the most significant bit. So when you write down the number, the answer will just be 10000. So that should be like what, 10,000. So this will just be 10,000. The base 2. And that is the item. So we try next one. Now they kind of catch them. We try next one. It's basically the same thing over and over. Once you catch them. The remainder is where the fun happens. Yeah. So I try next one. You see, like try 25, I guess. 25. I don't know. You pick any number. I doesn't want any big numbers, but I'll take her along to say right 25, you divide them by 2. So 25 divided by 2, you get 12, and the remainder will be like 1. Yeah, and you go again, right on the 12 here. 12 divided by 2 is what, like 6, and the remainder will be 0. And you bring on the 6 divided by 2, you get it 3, and the remainder will be 0. And you bring on the 3 divided by 2 again, you get what, 1. The remainder will be 1. You go again, 1 divided by 2, it's nothing. And what the remainder will be like 1? Yeah, 1. So you know, be from the bottom up. So this here will just be 1, 1, 0, 0, 1 to base 2. Yeah, that's I really the idea. It's not gonna change, right? Let's try next one. Let's try a bigger one and see. Yeah, let's try the bigger one. Trying to run around them big ones. Bigger along. But I think I'll pay enough table. I think I'll pay enough table. Should be able to do that. 126. Can I bring it down now? So that's one thing. Right, 126, same stuff divided by 2. That'll be like 63, you know. I can't remember how to do that, so I will just use my calculator. I'm already too good at mental maths. 63, yeah, I was correct. Jeez. All right, 63, the remainder was 0. So you go again, 63, you divide it by 2. That'll be like 31, 31, 31, yeah. What remainder is there? 1, yeah. 32, 31, I got 32. So 31 divided by 2 again, I get 15. Remainder could be like 1, yeah. Go again, 15 divided by 2, oh, that'll be like 7. Remainder could be 1, 7 divided by 2, well, that'll be like 3. Remainder will be 1. And you go again, 3 divided by 2 is like what, 1 divided by 2, right here, 1. And then 1 divided by 2 is nothing, and the remainder is 1. So the answer will just be 1, 1, 1. How much ones that is? 1, 2, 3, 4, 5, 6, and a 0. So 1, 2, 3, 4, 5, 6, and 0 to base 2. And that's the idea. Hope I explained that good. That's really the idea, right? Yeah, you're just gonna keep on doing it over and over. I like to use the table, practice this with the table a couple of times until they understand the steps. Then you can do whatever the frick you want after. Yeah, but you have to understand the core steps that you're doing to get the answer. Okay, if you don't, you'll confuse yourself a lot. So the quotient and the remainder is where you play now. That will actually be part of the number. When you're writing the number, that's from the most significant bit at the bottom up. Yeah. So I think I'll practice enough. I try one more, that's for good riddance. So 37, we convert that to binary. Divide by 2, 18. Right. 18, yeah. No. Yes, 18. 36. Yeah, remainder gonna be 1. 18 divided by 2 is that 9. Remainder gonna be 0. 9 divided by 2 is 4. Remainder gonna be 1. Then 4 divided by 2 is what? 2. Remainder 0. And then 2 divided by 2 is like 1. Remainder gonna be 0. And then 1 divided by 2 is 0. And 1. And this is the most significant bit. So the answer will just be 1, 0, 0, 1, 0, 1 to base 2. And that's it. That's all it is. That's why that's convert using the thing I show you. Yeah, but obviously I show you all the quicker method to use the shortcut one. You could use this method to do it also. Yeah. All right. So let you try going from the decimal to the octal. And you'll notice it's the same steps. It's not gonna change. It's literally not gonna change, right? So there you go. So you're going from octal now. So octal is 8. So instead of us dividing by 2, we divide it by 8 now. And it's the same idea. Okay, let's go and go and go and go and go until the quotient is 0. Yeah? Or until you cannot divide anymore. Yeah, so let's use one table for now. All right, let me try 135. I will need my calculator for this. Sure. All right, so there you go. So we convert into octal. So write 135 here and divided by 8 one time. So 135 divided by 8 16. Yeah, 16. Is that decimal? Yeah, 16. Oh, you mean that. Just calculate doesn't give you the remainder. And so 16 by 8 is what? So 128. So 128, 29, that'll be 7. All right, we go again. Divided by 8, that is what? 2. And the remainder is 0. And then you go 2 again. Well, 2 can be divided by 8. So the quotient is 0, and the remainder will be 2. And there's the most significant bit here. So this would just be 207 to octal is 8. Yeah, it's the same steps. Same step. We're looking for the remainder. The remainder will be the way you put it into the number. Yeah, let's switch forward this. You're just looking for the remainder. Yeah. If you calculate a doppy like mine, so give you the decimal answer. So you actually have to go and like subtract it. So, some calculators will give the fraction, so it'll be nice and easy for you to get. But my calculator are not that good. Tough. Let's try next one. You will notice that when you're doing it to octal, it's kind of boil down real fast. Because once you divide them by 8, the number will get smaller fast. So you can have less steps to do. Right? So like if you have like 65, once you divide this by 8, you don't to 8 one time. So watch it. If I convert this to octal, so write 65 divided by 8, 8 8s are 64. The remainder is 1. Go 8. You boil down to 8 already. And like you get 1. And then you get 1 divided by 8 is 0. Yeah, 1. That's crazy. You got a binary number. Wow. Yeah. So that's be like 101 to be sweet. It'll boil down real fast when you do the octal. The decimal with the 2, hey, I'll do more steps. Yeah. So that's all it is. That's literally all it is. That's all it is. Nothing more to say to your lives. Yeah, you're just dividing, you write the quotient. The quotient is where you're going to use to do the next thing again. And once you do the quotient, you write the remainder. The remainder is basically what going to go into the number. If you're doing it for to go to binary, you'll notice that the remainder is ever only 1 or 0. Yeah? That when they convert it to binary, the remainder only going to be 1 or 0. Yeah, when it convert it to octal, the remainder could be 0 to 7 because we know that is the octal number system, 0 to 7. Yeah, and that's it. That's all it is. Really all it is. Once you catch the pattern, then not gonna change. All right, so that is the idea for the no, that's whole numbers. When you're going from the whole numbers to the binary or the octal system. Yeah, that is all it is. The steps similar. All right, so now you can jump across to the fractional form. So the fractional form in simple terms is basically anything that have a decimal point with it. Just to make it simple so you can see. So anything you see like what 16.25 or something like that to base 10 and you want to convert it to octal or binary, yeah, you have to use these steps. I use these steps. But these are for whole numbers. These are for fractions. Yeah. So keep it in mind. Yeah. All right, nice. So the steps, you'll notice it's kind of parallel. So when you convert any fractions or whatever you want to convert it to, yeah. So instead of dividing, you multiply. Yeah. And about dividing, you multiply, right? And the same steps in this case, the thing that you keep on writing down, or the thing you have to keep in mind to use again and again and again and again and again and again, is whatever after decimal points. But let's make it real simple. So like if you had, let me say 4.5. Yeah. So if you had 4.5, you multiply by whatever base you want to convert it to. So if I multiply this by 2, I'll get 9 one time. Yeah. So you'll end up being 9.0. Yeah. And basically this is where we use again and again and again and again and again and again. Yeah. So obviously this was a bad example, but it's small. So you see, like if I had like 4.25, that's actually better to use. Once you multiply this by 2, you get 9.5. Yeah, and then you're using this 0.5 again down here, and you're just going to keep on repeating the steps. over and over and over and over and over. Yeah? So maybe asking, all right. So the thing we using over and over, we know is the thing after the decimal point. But now the thing that we actually had to use to put in the digits part is the whole number part. Wherever you get after you multiply is what will be part of the number. Yeah, so that is the little difference. And from before the remainder was where you're putting into the digits. Now the whole number, every time you multiply, is what we're going to wherever you're going to. Yeah. So step 4 is the same thing. Let's repeat step 1 to 3 using the value from step 2, which in this case is the decimal point. However, values after the decimal point. Yeah. And as I said before, you will stop when there's no decimal point, or basically when the decimal, wherever after the decimal point, go to 0. That way you're gonna know to stop, because 0 by anything is 0. Yeah, that way you're gonna know to stop. You have to stop anyway, you will just keep on getting 0, right? I just write the number from the first remainder down to the last. So you know it kind of inverted. You see that? This one for us from the last remainder to the top. This one is from the first to the last. So it inverted, kind of flipped. Why? Because when you're doing the division part and the multiplication part now, the most significant bit will always be the first one. Because that is the biggest number you will ever get. When you multiply whatever that first number by our base years, that is the first and the biggest number you'll ever get in the system. As you continue to use the decimal part, the number going to keep on getting smaller and smaller. So you're actually going to go from the most to the least. Yeah? But when you divide them now, you're going to go from the least to the most. Yeah? That is how the maths go. So that's very to remember it. Yeah? So, let's see if I could track something quickly. Hmm. Not that. Where did I put those notes? Here. Anyway, I want to try example. I think I had examples. So I try some. I could try the same thing. So let me try 0.625 to base 10. And you want to convert it to, like you see, you convert it to binary. It's the same stuff for the octal. So once you copy and paste it, it's the same idea. You just have to remember it. Yeah? So there you go. I think I have enough table, like a real column to this table. So we have a real table. Don't worry, so a real table. There you go. So we started, same idea, just have different order steps you're going through. So 0.625, right? So the steps, you must go into binary, binary is 2. So you multiply by 2. So let's see what I'll get. So 0.625 multiplied by 2. So 1, yeah, and the decimal part is 0.25, right? So remember, yeah, after the answer, I get the 1.25, right? But remember how we doing it in this case, this whole number here is what the bit will be, and this 0.25 here is where the magic will continue to happen, right? So in this column here, I'm not going to put 1.25, but I'm going to put 0.25, right? Because that is actually the fractional part. And the whole number part is where you're going to write into the bit where you convert it towards. Yeah, so it's kind of different, that's where you remember. And it's the same thing over again, so it'll be 0.25. Yeah, and multiply it by 2 again. So you end up with 0.5, right? So it has 0 in the whole number part, so it'll be 0 here. And you're going to use this 0.5 again, right? So it'll be 0.5, same thing, multiply by 2. You get 1.0. So this one here, we'll go to here. And look at that, you notice we get 0, and we stop. That literally what it is. Once you apply these steps and you know where you're pulling apart, you will know when to stop. Okay, Bruno tell you, you literally can't go anymore. Yeah, and that's the idea. Yeah. So you write the number multiply by 2. Once you multiply by 2, you will get a whole number part, a decimal point, and a little fractional part. You pull in the fractional part to go again, and the whole number part is where you're going to write in the bits section. Yeah, and as I said before, when you're writing this out, this here is the most significant bit, right? So this here in binary would have been 1, 0, 1, 2. Yeah. So the octal one, I might treat you too good. Octal don't treat you nice because multiplying 8 by anything, you had to go a while to actually get it to go to 0. Yeah. So I go and pick a, let's see if I can actually get one. 'Cause I don't want to pick one where I don't work out. Because obviously, still gonna pick one where it will work out, right? So I don't want to make up any cost. I think 175 should work. So I'll use 175. Yeah. So I try 175 to base 10. Um, yeah. Oh, shims. I want one with decimals. Are you treating me so bad? Right, 0.3125. I try that one. 0.3125. All right, it's here. 0.3125 to base 10, and I want to convert it to octal. Right, there you go. So same steps. It doesn't got change, right? So multiply by 8. So we put the calculator. 0.3125 multiply by 8. You get 2.5. But we know how to do this. We know the 2 go in here. And the 0.5 go and go right here. Yeah? And then we know we're going to use the 0.5 again, right? Multiply by 8. So 0.5 multiplied by 8. We get 4.0. So we know the 4 gone here. And since we get zero point 0, we will actually stop. Yeah? No, that was kind of real short. So we know this is the most significant bit. So we know the answer for this here. So 0.3125 to base 10. Then the octal system will just be 2, 4, and pay 8 at the bottom. Yeah? That's how it does. It's the same steps. He will always bring numbers that will work out real nice. So I go pick numbers that go work out real nice, right? Because as I say, if you make up a number, you'll be going over and over and over. Because there's only like a few numbers when you multiply by 8, you can actually get 0 out. Yeah? So if you know, like 8 by 5 is 40. The next one that will give you a 0 at the end. I himself know when that will be. Yeah? Just for fun, let me see. Like try and make up. Just to show like how fricked up we can actually get. Who knows, it might work out easy. So let me say 2.75 to base 10. Yeah? Let me see if you can convert that to octal, right? Let me see, just in case. So it shouldn't work out. If it's too long, I just gonna move on, but it's the same steps. So I multiply that by 8. Oh shit, just a comment. Let's see. So 2.75 multiplied by 8. Ooh, they got me 22 already. That's crazy. And that makes so much sense. So 22.0. Huh. They got me one time, yes? That's crazy. That actually makes sense. That's the answer already. Oh wow. Yeah. Well look at that. It's the same steps. You realize that some stuff kinda easier than others, but it's the same steps. Yeah. I get quotient as 0, so I stop. So that's the answer. 22. Base 8. Get done. Yeah. I don't know. It really matter what I say. Give. Let me try one that action I got work out. You see 3.82. Uh-huh. Let me try that. 3.82. I try to convert that to octal. So same steps, multiply by 8. Let's see. So like when you calculate 3.82, you multiply that by 8, you get 30.56. So you know the 30 can go here and the 0.56 can go here. Because we had to use that again here, right? Yeah, and then multiply by 8 again. So 0.56 multiplied by 8, 4.48. So we know the 4 gonna go here. And we go the 0.48 gonna go here. And we go again, multiply by 8. Okay, notice it's gonna be a long one. 3 point, so the 0.48 multiplied by 8, 3.84. So 3 here, and you get 0.84 here. I think I catch your point by now, but I just gonna continue to see if it actually work out. So 0.84 multiplied by 6.72. So you know the 0.72 will go here, 6 will go here. You gotta go again and again and again and again and again until I get a perfect number that actually give the coach the thing as 0. I'm not gonna do all that until long. Yeah. So in the exam, he will obviously bring numbers that one short and two will work out quick. Yeah. So once you know the steps, you're not gonna bring any long ass question to you. Yeah, you only have like something to the exam. But anyway, that's the steps to go from decimal to octal or binary. It's the same steps, it's similar. It's just that remember when you go into whole numbers, you divide them. When you use any fractional and go into whatever, you multiply. When you end the whole number, the quotient is where you can use over and over and over and over. And for the fractional form is the everything after the decimal point is where you're gonna be repeating over and over and over and over. Yeah? After the decimal point is where you're gonna repeat it. Yeah? When you're writing it, the remainder is the lowest order digit. You know, I explained to you what that means already. And for this one, the whole number is the most or the highest order digit. Yeah? So that's why this one is inverted. Because as I told you earlier, always write the number from the most significant. Yeah? So if something start high, everything else gonna be low. If something start low, the last one gonna be the highest. I repeat that again. If something start low, the last thing will be the highest. So it could be from low to high. If something start high, the last one will be the lowest. So just go from high to low. So that's why it's inverted. Yeah? And we'll step forward, just repeating the same steps. So that'll be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 until either the quotient go to 0 or the fractional part or the thing after the decimal point go to 0 if you're going from a fractional to whatever it is. Yeah? And I told you the writing when you're in the whole number, you write it from the lowest to the highest. And when you're in the fractional, from the highest to the lowest. And I already told you all, you always write the number from the most significant bit down to the lowest significant. Significant just means the number where the value bit is the highest. So remember, when you was converting to binary, you had 64, 32, 16, 8, 4, 2, and 1. Yeah? So like if I had a number, like we say 1001 to base 2, right? So 1001 will be 1001, right? So the number that would be the most significant bit here would be this one. Why? Because the value for this one is 8. So which means that this one here is 1 by 2 to the power 3. So this will be the most significant bit here. Yeah, that's what I mean by that. And obviously 1 will be the least because 1 attached to 2 to the power 0. Yeah, that's how it does it. Yeah, that's how it does it. So the most significant bit does not only be the number on the furthest left hand side. If you wanna keep it simple. That's how it does it. And the least is well the number furthest right. Yeah, counterintuitive, but simple once you remember. Yeah, it's very specific stuff. Once you practice a couple times, you remember the steps. It's simple. So I kind of like break down the steps as much as I could. And I didn't use any big words. So you should be able to read it and catch it, right? I didn't use no big words. Yeah, so nice. But it's not a language course. You're not gonna say explain fully how no, you're not gonna answer that. You just see what's gonna answer, convert, where's the answer? Yep, nice what you're gonna answer. Anyway, so that is steps. Alright, so then you start into the tables. When I give you all this, you all can actually use it to practice. Yeah, well, this was practice. Yeah. All right, nice. Last thing on the agenda, which is the last thing in the first lecture from Marcus. The other lectures, like with binary addition, subtraction, binary multiplication, which is simple stuff. You could probably do that in like after 2 minutes. Yeah. So go through that quick. And then the last one is like where you'll get like two's complements, which is basically representing like negative numbers. Yeah. So that's not to confuse you, but that's a little bit. So like if you have three, let's say we have three, right? And I want to convert that to binary, which you know already. You know, the shortcut and the long way. I just gonna use the shortcut, right? So I know I need 2 and 1, right? So it'll be 2 and 1 was, so it'd be 1 and 1. Yeah? So this here is binary. Okay? Normally, I know I jumped a bit, if you get confused now small. Normally, this is positive 3, right? We can see that is positive 3. That yellow is us. Right? We can see that is positive 3. Yeah? Everybody agree that is positive 3. This is positive 3. So you'll normally see something represented as a 3-digit binary code, or BCD for short. Yeah? 3-digit binary code, right? This is positive 3, right? So 0, we'll normally write 0, 1, 1. This 0 here, you use it to represent a positive number. Yeah? So 0, 1, 1 and binary is positive, positive 3. Yeah, because 1, 1 and binary is 3. Yeah? If I wanted to write negative 3 now in binary, this 0 here, if you're thinking a little bit, the opposite of 0 is 1. So therefore, 1 will be used to represent a negative number. So 3 will just be 1, 1, 1 to these 2. Yeah? It'll just call it signed binary because the binary have a sign up. Yeah? So that is literally all. That is all it is. Okay, let's explain in like 2 seconds or 10 seconds. Yeah? That's all it is. So 0 is for a positive. If 100 represent negative 3, I just go on and put it to be a 1 and look at that just so I get negative 3. Negative 3. Yeah. So when I give you the question, they will state that the numbers are represented as 3-digit binary codes. They will tell you. Or they will say as signed binary codes, meaning that the numbers actually have signs and it's not just positive all the time. Yeah. So that is a side note. Hope I didn't confuse you too much. All right. All right, again, this is the last thing, which is the easiest thing on the face of the earth. Going from hexadecimal to binary. Yeah. So remember I told you all if you go back to the thing on top here, right? So we know how to go from decimal to binary now. We know how to go from binary to decimal. Yeah, binary to decimal, you just use the table, right? I'll show you that as well, right? So octal to binary and hexadecimal to binary is what we're gonna do now. The binary back to the decimal thing, you can either use the table, they'll really ask it. But what you could just do is just use the shortcut method backwards. Yeah, so like if you have 1001 to base 2. I'll show you how to do it already. So this one here is 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2, and this is 2 to the power 3. And just add it up together. Yeah, so this would be 8. This would be 0. This would be 0. And this would be 1. So this is actually 9 and by decimal. Yeah, I'll just show you how to do it. When I showed you how to do it, this this is what it is. Yeah, that's what it is. Remember, as I told you, the decimal system is all the numbers that you could possibly use. 0 to 9, think about it. If you have 0 to 9, you could get any number on the face of the earth. So if somebody asks to convert some to decimal, they just wait to get the actual number that you will actually tell people when you're going in the market. Yeah? So it's the same thing. It does work it and back. Or if you don't want to do that long way, what I used to do, I have a big space. 1001111 to base 2, right? What I used to do, I know we're gonna go from 1 and there's 2, 4, 8, 16, and 32. So I remember I show you all already. So that's adding it up together. So this will be 1, 2, and this will be 4, 0, 0, and 32. And let's add it up together. 36, 37, 39, it'll be 39. Yeah, there are multiple ways to do, but this is general idea. Everything have a matching number. You multiply and you add. If you're not seeing it that way, do it like how we have now. We do it 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and you just go to the power 5 by 1 plus by that plus by this plus this by that plus that by that, add it up together, and you get the same answer. That don't really matter. But that's the idea. Yeah, that's the idea. Same thing for octal and the rest of them. Everything has powers to them. Yeah, so let's keep on remembering that. All right, nice. The same thing for octal. It would just be 8 to the power 0, 8 to the power 1, 8 to the power 2. Same thing. 16 to the power, the same idea. Yeah, because everything goes back to this. Everything goes back to this. Yeah, everything. All right, let's go back. So last thing on the agenda. All right, where was it? All right, this one. When you're going up from hexadecimal to binary, right? So remember, to your hexadecimal, let's go 0 to 9, and then let's go A, B, C, D, E, F. Yeah, so number, when you see the number, you will see like letters in it, which is only um applicable when you're talking about hexadecimal numbers, right? Because that is the only set of decimals system that has letters in them. Yeah, you only see a in the hexadecimal system. Yeah, so all I can really do for this, literally, I write it in red. You gotta write now the 4-digit representation for each digit. Yeah, that's all you're doing. And you're just writing it out. You're just gonna get a big macro long thing with ones and zeros, right? So 1 in hex in binary, 2 in binary, 3 in binary, and 8, which we know is 10 in binary, right? So we know 1 in binary, we know 1 was 1, right? So remember, is groups of 4. So yeah, how to like pad the other spaces with 0, right? So we know 1 is 1, so it'll just be 0, 0, 0, 1. Yeah, that's not padded. That's padded. Okay, so we get 4 groups of numbers, right? That's padded. So you can't write 1. Yeah, okay, you wouldn't get hexadecimal. This is supposed to end up with 16 digits. Yeah? So, and you have 4 here. So 4 by 4 is, last time I checked, 16, right? All right, so 2 are just, it'll be 0, 0, 1, 0, 1, 0. So you get 2 to the power 1, it'll be 1, 2, 4. So I could just use the 2 right there. Okay, flop, right? Then 3, I need the 1 and the 2. So it could be 0, 0, and 1, 1. 0, 0, 1, 1. Because 1, 2, 4, 8. Once you remember that, you've probably seen it by now. A is 10. So to get 10, I need the 8s. So it'll be 1. I don't need this. So it'll be 0, 1, 8, 4. I need the 2. I don't need the 0. Oh, I end up with 5 digits. I could erase that. 8, 4, 2. Yeah, 1. 8, 4, 2, 1 is 4. Okay, correct. I'm just going to erase the barrier right there. That making it look so confusing now. All right. Nice. All is well with the world now. All right. So that is it there. And that's one. So if you write it one after the other now, you're not going to keep the spaces. It would just be 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 0 to base 2. Yeah, that's the idea. You're just converting each number into its respective binary code. 4 digits, so that's pad the rest that you don't need. So this is 1, this is 2, this is 3, and this is 10, but we know me write it as A, right? I hope you all seeing that. Yeah, and that's it. And I'll show you how to convert it. You can probably like see it in your brain by now. Like if you want to convert 9, you know it's 1, 2, 8. So you need 8 and the 1. Like that's pad the rest with zeros. Yeah, anything you don't need, you just put 0, because 0 by anything is 0. Yeah. Think how the next example. Let's try this. So 4, so 4, 7, 3, A is 10, B will be 11, right? Yeah. So let's see how we could do this now. 4, so to get 4, I need, actually don't need anything, because 4, 2, 1. So it'll be 0, 1, 0, 0. Yeah. Remember, there's 1, there's 2, 4. Right? So 4, I can already get 4 flat. Yeah. 7, what I need? I need 6. No. I need 4, 2, and 1. So that'd be 0, 1, 1, 1. 3, I need 2 and 1. So I need the last 2. And the others will be zeros. And to get 11, we're going to need 8. We need 8. We will need 2. And we're going to need 1. So that'll be 8, 2, and 1. Yeah. All right. So let's put everything back together. 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1 to base 2. And that's it. That's all it is. Obviously, if you're probably asking, well, so how does go back from, you already know, just group it back into the 4 and just go backwards. You know how to read this off already. I'll show you all the ways you can read it. To go back from this to the decimal number, I already show you how to do it. So this will be 2 to the power 1, so it'll be 1 plus 2, and this will be 4 plus 8, so that's basically 11. Hey, look at that, 11. I just added, so 11. If you go into the hexadecimal, you know 11 will be B. And then you know this, when you read it off, this is 1, 2, 4, 8. So this will be 3. And this is 1, 2, 4 to be 7. And this will be 0, 0. This will be 4. Hey, when you look at that, about the same number. That's all. Nothing out of the ordinary. You're just going back and forth, back and yeah. Nice. Right. Right. Yeah. So last one, hexadecimal to octal. And that's really it for class. So the hexadecimal to octal, right? Remember, if I go back to the little diagram, I want you all to take a mental picture of it have no road or set of steps we could use to go from either of them, right? See that? I no link. No link. So I have to use the binary as a connected flight to go to the octal. Yeah? So that's what I really to remember this. Okay, will just make everything easier to see. Okay, you will know where you need to go to go where you want to go. Yeah? So just keep going back. Now go quick. All right, so you convert to binary. So that's the first step. I break it down into steps. Yeah, that's real simple. So anytime I hear convert to binary, it should be smiling, right? There's the same thing with one. Yeah. So 3 and binary, you already figure out what that is already. So let's write it out here. 3, A, 9, F. We know F is 50. And we know A is 10. All right, everything is good with the world. So 3 and binary, about 0, 0, 1, 1, right? A is 10, so I'll need 8 and 2. So 1, 2, whoa. No. That's incorrect. So it'll be 1 here, but this is 1, 2, 4, 8. Why did 8 from? That's so crazy. Anyway, so I'm gonna need here. So I'll need the 2, and I'll just need the 8. So I actually didn't need this 4 here. Yeah. So yeah, that should give me 10. 8 times this. So I need the 8. Oh my goodness. All right, so that gives me the answer 8, 2, yes, yeah. Yeah, so that I'm making mistakes, so like just see how to do quickly. Without making errors. Right, 9, same idea. So I'm gonna write it all like this. So I'm going to pick it up again. So to get 9, I need 8. I don't need 4. I don't need 2. I need 1. Right. Nice. And to get F is 15. So 1, 2, 4, 8. So I'll need the 8. I'll need the 4. 12, 13, 14. So it'll be 1, 1, 1, 1, right? Fair enough. Yeah, so nice. 1, 1, 1, 1. All right, so this is everything in binary. So check. Right, now is where the little stuff that's happening, right? You need to separate it into groups of 3, and you just go and ignore leading zeros. Leading zeros is basically where you have like 2 zeros back to back. So this is our leading 0 here. Yeah, you just go and ignore the first 0. Yeah, that's all it is. It's nothing more, nothing less. So we're gonna ignore you because use our leading 0. Don't need you now. So there's the first group of 3. There's the second group of 3. And you have a group of 3 here. So then you have a group of 3 here. And then you have a group of 3 here. Yeah? Seeing that? So now all you gonna do is just convert it to octal. So 0, 1, 1. Yeah? So we know this in binary as something, right? So remember, when you convert into octal, remember octal is similar to binary, but it only work from 0 to 7. Yeah? Remember that? So it has no A, B, C, E, F, G and thing for octal, right? So this here is 1 and 2, so this will just be, oh, I do need wrong thing. So I'm not sure how to do this. Remember in octal, right? So you know this is a to the power 0, a to the power 1, and we can continue. Yeah? So this will be a to the power 0, a to the power 1, a to the power 2, and the pattern can continue. A to the power 2, a to the power 1, a to the power 0, a to the power 2, a to the power 1, a to the power 0. Yeah? And you just add all of them up together. Yeah? I'm not feeling to do the maths now, but that's the idea. Why the base is 8 is because I need octa going to the octal system. So it's no longer 1, 2, 4, 8, 16, 32. Here is now 0, 8, 64. Well, 64 by 8 is whatever number. And they're going to go down here because I need octal are going to the octal system now. Yeah? And that's it. After you do the maths in your head, after you convert it into the groups of 3, that's going to be like, all right, 8 to the power 0, that 1, that is what, 8, 16, you add it up, you get an answer, you just add up everything together, and you're done. Yeah? And that's what it is. Yeah? And with that said, um, well, probably don't have to practice, right? But it's the same idea. Right? And with that said, I basically the number system. That's all what you need to know, and everything you need to know for the quiz. Well, the first part of the quiz. Right? So when you come next week, we'll go through the binary stuff. Let me just stop